and I'm trying to rearrange my office, so it's kind of a little bit of a chaotic thing right now. All right, so today we are going to continue looking at SQL and how we can get data out of our database. That'll be the primary goal tonight. I got a bunch of slides, and if we have time, we'll do some interactive coding. But if we don't, we'll do that on Thursday, because that's one of my favorite things to do. All right, so we have talked at length, or not at length, but we've talked a bunch about views and how they are a representation of data in one or more tables. A view does not store data on its own. It only kind of gives you a reference or a single way of looking at data, and it's created basically by a query definition. So when we create a view, we give it a name and we populate it in air quotes, because we're not really populating a table, but we're creating that view based on a SQL query. Postgres has something called a materialized view, and other databases do as well. It's not just a Postgres thing. But a materialized view is slightly different than a view, because it does actually copy and store data behind it. So when you're querying a regular view, you're querying the live tables behind the scenes. But when you query a materialized view, you're basically querying the data as of the last time it was refreshed. So consider a customer in an account, or a customer in a purchase table. If it's noon and we create our materialized view, and a customer comes in and makes a new purchase at 12:30, and we query our materialized view at 12:45, we might not see that purchase from the customer at 12:30, because it's effectively a snapshot at a point in time with the data that was part of that query. And so the syntax here for creating a materialized view is just the same as creating a view, but you put the word materialized in front of it. You give it a name and as your query, so whatever your query is. And so that as statement we can use in a couple of different syntax, or a couple different commands. So we can actually create a table as a query. When we create a table based on a query, it creates and copies the data into a new table. We've seen creating the views as the query behind it. But since that materialized view is a little bit different, we can constantly update that data. So there's a refresh command that you issue to the database to say, refresh this materialized view, and it will update the data that is in the materialized view. I'm very tempted to say in the table, but it's not a table. It's different. So the reason we do this is typically for performance reasons. So if we want to have a monthly sales summary, we can create the materialized view once, and we're not querying against that live transactional table that might be powering our e-commerce website. So if we and we're not doing large aggregation queries, which we're going to talk about in a minute, against that live transactional system, we can query this kind of stored snapshot data without affecting the primary data source. And I think that's all the notes I have in here. So you can't update the data in the materialized view, you can only read it. Does the concept of the materialized view versus a view make sense?
Yes.
Kind of.
I don't think we go too much more into this. I think the key things to take away is you are not hitting live data from the source tables. Like a view, whenever you access a view, you're essentially accessing the live tables behind it. But the materialized view is a snapshot of that data. That's the big difference.
Quick question.
Mm-hmm.
So I'm thinking that We have materialized view and view. So when should be the appropriate time that we should use materialized view
Yeah,
for us?
and so the times I've seen a materialized view actually used in a database has been for data that is the result of a really heavy computation. So if you imagine we have an inventory table for Amazon, you're going to have millions and millions of records within that table. If you wanted to find the average cost of all the products in that inventory table, you have to calculate the average across every single record in that table. You don't want to do that a lot because you will be affecting the performance of that table and the database as a whole. So we would create a materialized view that does that average of across the table, across a huge table, and then whenever we access that materialized view, we're not touching the table behind it. That only has to happen once, or whenever we refresh the materialized view. So those large aggregations can be, summarizing sales over time, getting an employee count for for some filing where you don't need to be super exact, but close enough is good enough. So, the sales example, if we wanted to find the average of the last 12 months of sales, that's great. If we're not 100% accurate on this month's data because it's not complete, that's okay. So we do that large aggregation of the historical data once and leave it like that.
Makes sense. Thank you.
Mm-hmm.
So this is something that to save performance, maybe companies with very large data sets will refresh during their off hours so that the next day they could run queries against that view.
Yep.
Okay.
Perfect. Yeah, that's a great example. Yeah, and another
VCU does that with their research data and all their grants information.
Yeah, makes a lot of sense because you don't need.
Because I helped write that code.
There you go. You don't need that up to date or up to the second data, right? You need up until the last time it was refreshed, which is probably nightly or weekly even. So whatever your schedule is, whether it's an hourly update or a daily update, that's up to you, and the things we'll determine when we're looking at performance of the database, and how accurate and up to date our data needs to be that we're querying. So another use could be kind of almost a caching strategy. Like one of the applications I work on is a heavily used API to read data out of a database. That data hardly ever changes. And so one of the ways we could save performance on the core tables is by creating a materialized view on top of those and getting that from our application. But in that case, maybe we update it every 30 seconds, but that's a lot better than hitting those raw tables 4,000 times per second. Something like that. So yeah, it's often much faster than getting data from underneath from the underlying tables. So here was that example of the invoices, where we've got a table with invoice numbers, seller numbers, dates, and amounts. And if we wanted to look at that historical data, we could create that materialized view with our sales summary. So in this case, the query is performing looks like a daily invoice date. Yeah, so a daily sales number for our application.
Professor,
Mm-hmm.
I have a quick question. I see that in the create table invoice, there is a invoice amount which is numeric.
Mm-hmm.
But though it is numeric, it's like precision and scale. So what is the difference between, like if I give decimal, will it be wrong? Or when do you choose numeric? When do you choose decimal?
I would have to look for like the academic reason on why you use one over the other for accuracy. Because I know there was another data type for currency, right? Which I think is just I'm trying to remember if it was a numeric or what database, what data type was underneath of it, but it was all really about presentation. So we can try to research that one and figure out the proper answer when you're dealing with money. Some people do money in very different ways, because rounding of money and all that kind of stuff.
But it's not wrong, Professor, to use either one of them.
Or using a numeric or what?
Or decimal.
Decimal.
Decimal. Off the top of my head, I don't think so. Especially if you're just storing something like an invoice where it is a to the cents and you never get to a smaller precision than cents, then this numeric with a 2 precision is just fine.
Yeah. Okay, Professor. Thank you.
Mm-hmm. So this query is a we're going to talk about group bys and all that in the aggregation soon, but all this materialized view is doing a query for summarizing by day by seller number. So you can find your sales per seller per day. Now we'll go into how we built that query in a little bit. Then we have that refresh command to update the data behind it. All right, so I want to talk more about different ways we can query data out of the database. More kind of commands or filter scenarios for when we're querying data. So there's a distinct keyword when you are querying your database that allows you to remove duplicate rows. So a way or how that would look in a real database, imagine we have a table T1 with an ID serial and then 2 varchars, so a background color and a foreground color. And in that table, we have a whole bunch of combinations of colors. Red, 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 null, null, red, etc. If we select everything from that table, select star from T1, that is getting everything from the table, I pull back every record in that table. So I get the IDs, the color, the background color, and the foreground color. Now let's say I wanted to, when I click, it's supposed to move. Oops. There we go. Get a distinct list of background colors from the database. I can issue the command select distinct B color, background color from T1. And then I get a smaller list of unique values for that query. So in this case, you can see I got 4 rows. One, I put a little annotation. That's not what null looks like, but null, green, blue, and red. I don't have 7 greens. I don't have 12 reds. I just get the distinct colors in there. And this can be issued on a query with multiple columns. So if you get background and foreground, you could get a unique row. So you wouldn't get duplicate rows of the same combination. Easy enough?
I have a quick question, Professor.
Of course.
How is there a way that we can count distinct and count or select whatever? Select or count distinct and unique.
So if
Because
if I wanted to see how many greens there were?
because I think distinct and unique, they are 2 different terms, and we are just counting or select. We are selecting distinct values, but is there a way that we can do with a unique value as well?
I'm not sure I'm aware of unique being a keyword.
Because in other calculation techniques, we did have distinct and unique values. It's kind of like if you have no duplication, if you have duplication, it's distinct, but if it doesn't have duplication, it's unique. So we are counting and we're selecting distinct right now, but is there a way that we can do with SQL that we can count unique?
So you would only want to return rows or values that are unique. Okay, yes, we most absolutely can do that, and we should be able to do that by the end of tonight's lecture.
That's great.
In the first way I can think of. Assuming there is no unique keyword, but there might be, but I'm not aware of it.
There's a unique constraint, I think.
There is a unique constraint, absolutely.
That would bring up like every row that's.
Well, no, because the constraint will be on it's a rule for putting data into the table.
Right.
So you couldn't put in duplicates.
Right.
Versus here, we're trying to get the unique values on query. But I think she's asking, is there a way to find the unique value that isn't duplicated?
Right. And then like account of that.
Exactly. That's where I'm going in my head. So I think when we talk through aggregations, we'll be able to do that. Joining data, we had a little sneak of that previously, but there are a bunch of different join types. So inner joins are kind of the, I don't want to even say most popular, but an inner join only returns rows that have a common value in your two tables. So to follow the picture, an inner join returns values that match in A and B on a primary and foreign key. So when you're inner joining a table, and let's say we'll go to our customer and invoice table. If we inner join those two tables, it will not return customers that don't have an invoice. It will only return customers that do have an invoice if the customer ID is a foreign key on the invoice table. So when there's that match, an inner join will only return those records. Okay? I'm watching eyes for the 3 people I can see. Thumbs ups. Cool. Left outer joins. Customer is A. Invoice is B. A left outer join on the customer table and the invoice table will return all the records from customer and will match them to the invoice if there's the same value. But in cases where there is no invoice for the customer, you'll get a bunch of null values. So if we left outer join on A customer, joining to B invoice, we will return all records in A, all customers. And if there is a match on the invoice table, we'll join those invoice records. But if not, we'll get empty or null values. Then flipping that to the other side, if again, A being customers, B being invoices, if we right outer join on those tables, we'll get all invoices whether or not there is a customer associated with them. So if that's a nullable foreign key almost. That example is a weird one, and I'm not sure we would ever have that scenario, but that's how it would play out with a right outer join.
Are left and right joins, do they kind of just come down to personal preference or something? Because it seems like you could just flip table B to A
and make it a left outer join. Yeah. And so I don't think I can ever come up with a scenario that I've written a right outer join for.
Mm-hmm.
Because whenever you're querying data, what's that?
I said me neither.
Yeah. It can happen, but I guess I don't know why it would happen. Because whenever you're querying data, you're always kind of grounded in something. So you're always asking a question about a customer, right? Or you're always asking a question about a product. And you know that product is going to exist, whether it got sold or not. The product exists. So you're grounded on column A. Or table A customer. And everything is related to customer. whether it's one join or three joins, it doesn't matter. It's always routed back to the customer. And so when I write my queries, when I select whatever from table A, it's always customer. And then the joins are always on something else. And so if those don't exist, I do my left outer joins. What I do it the other way, I have no idea. I'd have to Google and find a good example. If anyone wants to do that while we're talking and comes up with a good example, I'd be happy to hear it. But I can't come up with one. So a full outer join is kind of a combination of all of the above. If I'm selecting customers and invoices, whether there's an association or not, if there's an association, they'll get joined together. If there's not, I might get nulls in my customer, I might get nulls in my invoice. So I want all my records, whether they match or not. I could see maybe doing that.
But at that point, wouldn't you? It's the same as like just selecting all the values of your tables and just printing that out. Like, is there really any point?
Yeah,
Doing
no.
everything to everything and just breaking something.
Great question. So the I guess the worst case scenario is the Cartesian join, right? Where you select star from two tables, and that's it. And then you get, a weird fake relationship created in your result set where you get for every record in table A, it's returned with every record from table B. So it's that exponential join kind of thing. The outer join would at least give you that cardinality to say, when they match, put them together to avoid that Cartesian join.
I found a use case for a right outer join.
All right, bring it.
If your native language goes from right to left instead of what we're used to with left to right, it's easier visually and mentally, I guess.
So it is a personal preference.
To some extent, yeah.
Nothing practical for what we're talking about there.
Yeah. So there's no like data scenario where you can, and that's not a thing to discredit. I mean, obviously there are many more people in the world, and I think if I did them probably that read right to left and not left to right. But I guess that is my English bias of left to right, where the left outer join is what I do. You'll see it in each of these boxes. They are they have kind of the what are these? These are Venn diagrams with the middle overlapping section either where they match or where they don't match. And so you can build your queries in such a way that your result set, let's say we're doing the left outer join on customers and invoices, where we only return customers without a matching invoice. Wait, is that right? B is null. No, that doesn't make sense either. A equals B, A equals B, where B is null. Why would I do that? Again, I'd have to come up with a weird scenario to do that. So the Venn diagrams on the top of the left and right outer join boxes, I think they're the most natural. Oh, yeah. I think the second example is the inverse. That's what it is. The second example is an inverse. I have SQL. Why do I have SQL? Oh no. Well, I guess I forgot to add it to my GitHub repository. Let's skip that SQL. Where clauses. So a where clause is used to filter data in your result set. So there is a where keyword. And rows that are returned match whatever the condition is in your where clause. So the syntax for this query, select is the magic query word. You can list the columns you want returned. You can use a star for all columns or a specific list of columns from your table or tables, where whatever condition you want to meet. So here I'm selecting star from employees where employee ID equals 4. So if I want to get all the information about a specific employee, I would have a where clause where employee ID equals 4. So that's a pretty straightforward equality check. So if we have 17 million records in our employees table, we would only return any row that matches on employee ID value 4. And if employee ID is a primary key, we will only get one row returned. There are lots of permutations of these conditions. You can perform conditional checks on all the data types, not just numbers. So if we're comparing strings, if our make field is a string, we can say where make equals Ford. We're building a car selling website. So if anybody wants to work at CarMax, these might be great examples to go into and say, I know how to query on mileage. Select star from car where mileage is less than 250,000. So less than, equal to, greater than, not equal to, all of those exist. You can have multiple conditions to meet. Number of doors is greater than 3, and number of owners is less than or equal to 2. So less than or equal to is a comparison. We can perform math while we're doing this. So if I want to select whatever these magic B and A columns are from my table T, I can perform division. B divided by A is greater than 0.5, and A does not equal 0. There are scenarios, obviously, in this case where you could divide by 0 and things break. So don't divide by 0. So that's why we have A does not equal 0 comparison. Math, less than, equal to, greater than, equal to, or not equal to. You can do a between. So the column X is between value A and value B. That is inclusive. If you're doing date ranges, you can check if two date ranges overlap. So every time you see something hard-coded like this, like a specific date, that can be a data in a column as well. So if I were looking for an event that happened or a range that overlapped an event, and I were building an application to do so, I would probably have the data in the table, column start time or start date, column end date, overlaps whatever my user input was. So I want to see all of the overnight camping events from last week. I would select camping start date, camping end date, seeing if it overlaps whatever parameters I pass in, the start and the end of last week, or something like that. So just because they're hard-coded doesn't mean they have to be.
Professor, that between the first part I understood, the second part inclusive, I couldn't catch it.
So where X is between A and B, it's an inclusive check, which means X could equal A and X could equal B. So it's equivalent of X is greater than or equal to A and X is less than or equal to B.
Okay.
As opposed to an exclusive check, it wouldn't be greater than or equal to, it would be just greater than or just less than. That would be exclusive. So inclusive means the extremes of that value range you're querying for.
Okay. Thank you.
Great question. Paying attention. I like it. All right. Depending on your data type, you have all kinds of different conditionals. Strings have kind of substring matching. They have starts with, so you can check if a string starts with another string or ends with another string. There's a whole lot of other details we can query by for these conditions. And over time, we'll get into more of those. But there's probably 3 chapters just on that, or 3 weeks we could do just on that topic, and that'd be really boring. Because there's a lot of cool stuff a Postgres database can do. Because remember we talked about briefly about the geo or the Cartesian table or graph XY kind of coordinates, line segments and circles and and points and those kind of things. All of those are comparable for things like between and overlaps and intersects, and there's all kinds of cool conditionals there too. And as much as I love that geo stuff, we won't really use it all that much in this class. But if you're ever curious, that's a fun thing to look into. All right, now I think where we're going to start, I think, to answer that unique question from earlier, this grouping is where we can start to do that. So the group by statement in SQL is used to arrange identical data into groups with the help of some functions. If a particular column has the same value in different rows, then it will arrange these rows by groups. So the syntax for this, if we are selecting data from the table, whenever we group by things, we tend to perform aggregate functionality or aggregate functions on them. So column 1, first name, function name, sum, count, average, all those kind of things of another column. From table where condition, group by column 1 and column 2. That's not valid SQL. That's not SQL. Don't read that. I'll show examples in a second. So the function name can be things like sum and average. Table and conditions are regular. So select from where being the conditions. Those don't change. That's always how we query a database. So some examples here. I like cars a lot, so a lot of my examples have to do with cars. So here we have a table about cars, make, model, and price. Make, model, year, and price. So here you can see I have 3 Ford Flexes, 2 BMW 330i's, different years, different prices, etc. So I want to select my make and model, and I want to count them. So how many Ford Flexes do I have? How many BMW 330i's do I have? The way I do that, I'm selecting make, model, and count. Count is my aggregate function from my car for sale table, and I'm grouping by make and model. So any column that is not grouped by, you must perform an aggregate function call on in my result. So here I'm doing star is not really a column, but this could be price, this could be make. It doesn't really matter. Maybe it couldn't be make. Anyway, I'm not performing an aggregate function on make and model because I'm grouping by make and model. But I am performing an aggregate to count how many match that make and model. So my result set would look like Ford Flex 3 because I have 3 Ford Flexes. I need to make my examples match. Oh no, I dotted. So there's anything behind that dot. So in my dots, I have a total of 7 BMW 330i's and 9 Honda Civics. So if I looked at the raw table with all of that data behind it, I would see 7 rows for BMW 330i's. I would see 9 rows for Honda Civic. But since I'm grouping by make and model, it's finding the unique, distinct. It's finding the same word in my head, the distinct combination of make and model, and then performing the aggregate function on whatever else I'm returning. In this case, I want to count how many there are. Here's where I think we would build that query for a where to meet your unique clause. Here I can, instead of a where condition, since we're performing aggregations, we have an equivalent to the where, but it's having. So the having keyword is only used when you're comparing the value from your aggregate function. So select make model count star, and I'm giving it an alias here of C. So if I ran this query in a SQL developer, in a SQL developer, Toad, command line, whatever, I would get see in my example again that should say C. That column would look like C. It would be named C. So I do that so I can then reference it in my having clause. So this query select make model count star as C from car for sale, group by make and model, having C greater than 7. So my return will only be anything with that count greater than 7. So if I were looking for unique values, I could execute this query having C equals 1. That'll give me my unique values.
That makes sense. Yeah.
I saw a question in the chat from earlier. When was that question, Jess? Which slide?
I think you answered it when you said no, don't do that.
This.
Where it's like, yeah.
Yeah, don't
I
do
think
that.
you already answered it. Okay, cool.
Yeah. Having. And so for the having clauses or the having conditions, you have every conditional that you had before, greater than, less than, equal to, not equal to, etc. But you got to remember you are performing that check against the aggregate value. If we were in a classroom and I had a big old whiteboard, I would draw, and I don't really find, my iPad's over there. There's a pipeline for this. The way the query engine works. The first thing your query engine does is it finds the rows in your table. So I'm selecting make and model from my table. So if I just select make model from table, I get all those rows back. If I'm grouping by, it has to have all those values to be able to find the unique combinations. So that next stage is grouping. Well, step back. Before I group, if I had a where clause, that where clause would be applied to each row in my result set, filtering out things that don't match the where clause. Then I group by to get those combinations, perform my aggregate functions, etc. And once I'm done my group by to have those values for my aggregate functions, then I can apply the having statement. So it's kind of the order that things happen behind the scenes in the database. That's why we have a different clause for where and having. It's kind of like building a cake. First layer of the cake is the data in the table. Second layer of the cake is filtered with your where clause. Third layer of the cake is your aggregate functions. Fourth layer is your having conditionals. I don't know why I went with cake, but whatever. Maybe I'm hungry. Any questions on having? I know the example is super, super simple, but these queries can be as complex as you want them to be. I'm just trying to show it in a very simple context. There can be joins in here. There can be aggregation function on joins, etc. All right.
I have a quick question.
Of course.
Is there a way that you can select everything but accept like one column, one field? So we still can use asterisk, but I just wonder if we can like remove or deselect any column.
Not that I know of without having to write out all the column names except for the one you don't want.
Because I do believe we might have to deal with a set of multiple fields, a lot of fields, and we really don't want to list out everything kind of time consuming.
Yeah.
So yeah, so if there's another way, because I know in R we can do that, we write a code with select everything, but only one column is exception. I'm not sure if SQL can do the same thing.
I am not aware, but I'm gonna write it down and look for it.
I have like at work a just Excel template, like just a simple formula that puts a column. That puts a comma after each field, so I can paste like 50 fields, and it'll just create the select statement for me. So there's like workarounds you can do, so you don't have to type it out. You can just make like a quick Excel formula after you paste all the columns you want, like from a data dictionary or something.
And
that's really smart.
Yeah, that's probably exactly what I would do. I would probably query the system table to find all the columns for this table, and then just subtract the one value I don't want, and then format that into a query. Yeah, so it's very similar. Good question, though. And the last thing in that query is ordering your results. So if you want them to come out of your query in a specific order based on time ranges or alphabetical sorting or numerical sorting, there's an order by clause as well. And so you can do ascending or descending sorting. It doesn't really matter. So the examples here: select make model count *C from cars, group by make model, order by C descending. Using non-technical words, what is that query doing for me? In our car for sale use business.
Put the highest number at the beginning of the table.
And what does the highest number represent?
The number of cars belongs to each model. For example, Honda Civic is 9, so it will be the first one.
Yep, that's exactly right. So this is how I'm answering the question. Show me the cars you have in stock, sorted by the most popular. Select make model price from cars, order by price ascending. What will be the first result in that one?
The most expensive, or no, cheapest.
Cheapest. Yep, the most.
Yeah,
the least expensive.
The least expensive.
Yep.
Yep.
Here's a tricky one. Select make model price from cars, order by 1, 2, price ascending. I want to see if you can guess, because I haven't told you what 1, 2 is yet.
Refer to the column, maybe?
Yep, exactly. So it's the first and the second column. So what would this query look, or what would the results of this query look like on a website?
So basically it will arrange, like, it will hold the first column, arrange these values ascending, then move to the next one, then third one.
So in our cars model, what would it look like?
I think we could have a make and model of the least expensive car.
Well, you would see the make first, and then the models listed by price. Well, the make, and then the models listed, and then if there's any different prices in the models, you'd see the
Yep.
price.
So I would see all my Fords first.
Mm-hmm.
And in my Fords, I would see all my Flexes, then my F-150s, then my Mustangs, and my whatever. And in each of those, if I had multiple Flexes, I would see the cheapest first. Yep. So So you can start doing a lot of fun stuff here. The reason I have this is just to show you that it doesn't have to be the column name. It can be the ordinal representation of the column in the result set. I don't think I've ever done that in practice though, because that's a heck of a lot harder to understand than just give me the column name. But I guess if I didn't want to alias my count, I could order by 3 instead. We've done a little bit of inserting data into our tables. So I guess I lied when I said we were only talking about querying. Inserting into cars, I'm going to insert into is my command. Cars is my table. Oh, good golly, come back here. Then the columns I am going to insert data into of that table. The values, then the list of values. So the columns are in parentheses and the values are in parentheses. I can insert more than one row in one insert statement. They're just comma separated. So here I'm inserting a Ford Focus and a Honda Civic within one SQL insert statement. I could also create, for whatever reason, a new table. Or in this case, I'm inserting into an existing table. I'm inserting into the expensive cars table, make, model, year, price, the values from a query. What else could I do to kind of make this, or what's a different way I could make this happen for an application to be able to query just expensive cars? That we've talked about.
View?
Melody, what were you saying?
Oh, I was just about to say, if we can do range, like we can do case and if then else, you know. So if we have a range of expensive cars, and we just have to put in there like the case and else, and then the end different argument, and we can have a list of expensive cars.
Yeah, I was thinking the view. You could have a view for this as well. But, you know, there are always lots of ways to solve problems. We can change data that is in a table using the update statement. So here I'm updating a table, updating T. I'm setting the column F to be F plus 1, where ID equals 5. So this is a way I can increment a counter or something like that on a table here. But see, the thing, what this is showing is that I can change the value based on the current value. So if at the time of my executing this update statement, F is set to 0, the field is 0, and then I update T, set F equals F plus 1, where ID equals 5, it would become 1. If I run it again, it would become 2, and then 3, etc. Or I can just set it to a hard-coded value here. So update T.
Does T represent table?
Mm-hmm. Yep.
Okay.
That's my poor naming of a table example.
So we really don't have to specify table to update table T, only the
Correct.
name of the
It's
table.
just update and then the table name. And I think these should be single quotes as well for the string.
In Postgres, it should be single,
Yep.
but in SQL like Oracle, it can be both. But in Postgres, I remember only single.
Yep. Deleting. I don't know why this is in here twice, but we can permanently remove a record from a database table. So the first example, delete from T, where ID equals 120. So if there is a row that the ID equals 120, it would be deleted. Delete from car where make equals Porsche, if I want to get rid of all my Porsches. Returning star returns all the values that got deleted. So returning, I don't know if that's just Postgres or not. I'm not sure. This is a way your application could report or something like that, everything that got deleted. So if I didn't return star in that example, when I run this query, I have no idea what happens. It might tell me how many rows are deleted. In this case, it would usually be 1 at most. But if I ran just delete from car where make equals Porsche, I might just know how many I deleted. If I returning star, then I would effectively have a result set that I could access in my application to know what I deleted.
Is that a keyword, Professor, returning?
Mm-hmm. It is.
Pretty sure you can do return and returning in regular, or not just Postgres.
Okay. Yeah, I've been stuck in Postgres for so long now. I can't remember other databases much.
So the product from that query it returns the records or multiple records that we have deleted.
Correct.
Is that a way? If in the case it's gonna be like 1,000 or hundreds of records, is that a way that we can see just an aggregate number, like count how many rows that we have deleted? I think it's better than just look at the whole list of deleted records.
Mm-hmm. So that's one thing I would experiment with and see if I could perform an aggregate function there. I could see return count star. I don't know the answer offhand though.
Well, we can try it out.
Exactly.
On Thursday.
This is why I love computers. It's just data. If you're messing around on your local computer, it doesn't matter if you delete stuff. Especially when you have a script, it'll just insert it right back again. Truncating is another way to remove data from a table, but it deletes everything from the table, leaving the table. It doesn't delete the table, it just removes all the records from the table. This is equivalent functionally to delete from cars, with no where clause or anything like that. If I execute delete from cars, the database engine goes and deletes every single row in the table, one by one, one by one. If you have 75 million records in your table, that actually could take some time to delete all the records. Truncating all that data just removes it all in one operation. So it's a much, much faster way of deleting large data sets. I usually get questions on that one. Make sense?
Yep.
All right, this is a fun part. So, over the rest of the semester, we have been talking about mic spikes a lot. I want each of you to come up with your own application or your own SQL, your own business or problem you're solving with a database. Historically, I've had students try to solve a problem they have at work, or do some data modeling around VCU and school, like a relationship between classes and students and all that kind of stuff. But I want to go through the process that this book defines for analyzing and creating a database with your own story. So as part of that, it will be free to you to kind of come up with your own idea. But I want you to kind of put some thought behind what problem you're solving. So we'll eventually do a write-up on that. Then we will design the database with our ER diagrams, talking about our relationship cardinality. We'll name our tables. We'll add columns and data types, primary and foreign keys. We'll build SQL to generate them, SQL to insert data, a whole bunch of SQL to query the data. And I want it to be decent sized. So 10 is kind of an arbitrary number I made up, but I think anything less than 10 would be easy. But if you think of any problem, it'd probably be pretty easy to come up with a reason to have 10 database tables. So this is nothing being assigned right now. The official assignment will come on Thursday, and I'll come through with some examples that if you can't come up with one on your own, you can kind of choose from if you want. But if you can make this something that affects you in real life, I think it'll mean something more. So I like it when students come into something that is challenging them at work. One of my students last semester was designing a table for where he worked. He was trying to do some reporting that they were unable to do today. And so he built this whole database schema around employees, their privileges on the computers they have access to, and that kind of stuff, kind of do some auditing. It was really neat. And so I want you to, if you can come up with something related to you, that'd be awesome. If not, I'll have some ideas.
So, hey, Chris.
Yep.
Quick question about this assignment. So I think next assignment is about the mic spikes.
Yep.
Now, when do we stop using mic spikes as assignments or projects? So we stop there, and then use our own projects going forward?
I might have a combination of the two for a week or two overlapping, because this is going to be a significant project for basically the remainder of the semester. But we won't be doing much more into mic spikes. I know we have an assignment due tomorrow for your SQL, right? If I remember correctly.
Yes.
Yeah. And I'm not sure if I will take that to the next step of data. But if I do, it'll just be like one more thing inserting data, and that's probably it. Because this is going to be the fun one.
And I totally agree.
I'm glad. I'm glad you agree. Because I think as a graduate level course, it makes more sense to do something you can apply to your life. Whether it's work, whether it's hobbies, whether it's personal interests, it doesn't matter to me. But I want you to think about a scenario you have in real life and figure out how to model it. Unless one of you owns a bike store and want to continue on the bike store. But I don't think any of you own a bike store. Does anybody own a bike store? I didn't think so. I got a question. Can we use our actual tables at work? So you have an employee agreement with where you work on what you can share publicly or not. If you want to share an actual challenge you have at work to model something new, I would kind of get permission from work before I did so. You know, and I would want to figure out how I would want to figure out what I don't want is if you already work on an application at work, I don't want you to just copy and paste something and try to give it to me as an assignment, because I probably wouldn't know. You're only, you don't, that's not what you're asking, I realize. But I want you to come up with something and learn.
Sorry, Professor.
Yep.
The project has to be done in PostgreSQL, correct?
Yep.
Much like everything else.
Yep.
Okay. So we can't use any other database system like MySQL or Microsoft SQL. Just wondering.
I need to make it easier for me, so no.
Okay.
last time I taught the class, I had 11 students. If I had 11 in a class, I'd maybe be able to be more flexible, but not with 25 of y'all. I just can't do it.
Gotcha. It's all good. I just wanted to try out different softwares, but
Yeah.
Postgre works very well with me.
Yeah, and it like as long as you stick to kind of like standard SQL, whatever you do in Postgres will work in MySQL. Microsoft always screws everything up, so I don't know what they would have, but try it, see what happens, see how they change, right? Because I know the serial pseudotype. I'm not sure if that. I know there's an auto incrementing number in MySQL, so they're a little different, but they have the same functionality.
Gotcha.
But I will be running everything against Postgres just to make my life easier.
I get that. Thank you.
Yep. So nothing due on this one immediately, but start thinking about it, and I will figure out a way to get this started on an assignment and assign it on Thursday. So that is it for this evening. Let me stop my recording.